Hey guys, welcome back to my channel. Today we're going to talk about virtual LAN. So this is a layer 2 concept. When I say layer 2, it basically means it belongs to one particular network or one local area network. If I say it's a layer 2 protocol, that means this protocol runs within the network. If I say it's a layer 3 protocol, then it's related to routing. When it says it's layer 4, it's transport. When it's a layer 5, it's generally application layer protocol. So this concept virtual LAN is a layer 2 concept. So what is virtual LAN, right? It is used to divide a traditional LAN into multiple smaller logical LANs without having to use more switches and routers. As we have discussed before, a local area network is something where it covers a smaller distance, smaller geographical area. So let's say we have a room where we have one network where I have 10 computers in the room. Okay, 3 belong to the IT department, 3 belong to the sales department, and 4 belong to the finance department. So I have 10 computers in one room, which is part of one network. So this is my local area network. Okay, now let's say I don't want the IT people to communicate with the sales people or the finance people. I want them to be independent. Okay, so what do I do? And I want them to be a part of different networks. I don't want them to be on the same network, right? But because they're connected to the same internet, they are part of one network only, right? So let's say I have a Wi-Fi router and 10 computers are connected to the same Wi-Fi router, then all of them would have an IP address in the same network. For example, 192.168.1.0/24 network. But let's say I don't want them to be in one network. I don't want them to be able to communicate with each other. I want I want to manage these networks like independently. Like I want IT to be like a different network, sales department to be a different network, and finance department to be a different network. So what do I do in this case? In this case, I'll basically use a virtual LAN, a VLAN, and divide them into three different LANs. Or I could use three switches, connect them to three switches, and then connect them to a router so they are able to communicate with each other, right? But using more number of switches and a router is not cost efficient, right? It's more hardware. So what do? We can use a VLAN. Now we have seen use cases where we have to broadcast the packets to learn the ARP address, or even in some protocols like DHCP, we saw that we have to send a broadcast message to learn some information. So what happens if all of them are in one network? That means all of them would receive this packet, right? A broadcast packet. This would also cause them to reply back to the device which sent them the broadcast packet, and this will cause congestion in the network, right? The bandwidth will be congested. So it could be, this could be one of the reasons. Say 10 computers in one room is still manageable, but what if there are like 100 computers? What if I am running a university and I need to have computers from different departments like electronics departments, mechanical department, chemical department, biotechnology, biomedical, admin, fee structures, and all of this have separate departments, right? So all of them being in one part of the department, and just because one device wants to learn about a device, let's say I want one mechanical engineer computer to be communicating with another one, it will have to send a broadcast packet to learn its up to all these devices which are part of like the same network, right? Could be hundreds, could be thousands. So what do? I just divide them into a smaller LANs, right, using VLANs, and these broadcast packets will be only sent to those computers part of the same VLAN, right? So if I have, for example, in my example, right, I have 10 computers in a room, 3 belong to IT. So if two of them want to communicate with each other and they want to learn each other's up, the broadcast packet will be only be sent to these three computers instead of sending it to all the other 7 computers. Okay, in total 10 computers, right? So instead of sending it to the other 9, it will just send it to the other 2 which are part of the same network, right? So this way the broadcast domain is reduced, right? It's also, if you're dividing them into multiple sublans, it's easier to manage, it's more secure, where IT is not able to talk to finance. It's also easier in troubleshooting and debugging issues if they arise. So this is generally why we use virtual LAN. So guys, let me show you how the VLANs would work. So let's say I have a device called PC1. Okay, I have PC1 and have one more device called PC2. Okay, and I have a switch called, this is my switch called switch A. Okay, now this PC1 is connected to switch A, PC2 is also connected to switch A. This is connected to interface 1, this is connected to interface 2. Okay, PC1 has an IP address of 192.168.1.2, and let's say this is also part of 192.168.1.3. Okay, so both PC1 and PC2 are part of the same network, right? So if PC1 wants to communicate with PC2, this communication will be possible because PC1 will forward the packet to the switch A based on the ARP resolution and learning of the MAC addresses. Switch A knows that this packet needs to go to PC2, and it will forward the packet out of the interface 2, and PC2 will receive the packet. So this communication is possible when devices are in the same network. Okay, but what if I don't want these devices to be part of the same network? What do I do in that case? Right? In that case, let me first change the IP of the PC2. Right? Let me make it as 10.1.1.2. Now PC1 and PC2 are part of different networks. Okay. Now let's say I want them to be able to communicate with each other. Right? What do I do in this case? In this case, I'll have now PC1 and PC2 will not be able to communicate with each other since switch A is a purely layer 2 switch. It does not have any routing capability. But we can configure the PC1 to be part of one VLAN and PC2 to be part of the another VLAN. Okay, that's possible. Now what's another way for them to be able to communicate with each other? Right, for them to be able to communicate with each other, right? The other way is, let's say I have PC1 which is connected to a switch A, and I have PC2 which is connected to switch B. Okay, now let's say I have one more PC over here, part of same network, PC3. I have one more network over here which is part of PC4. Okay, now let's say both of them are connected to a router. Okay, now this is part of 192.168.1.1 network, and this interface is part of 10.1.1.1. Now when PC1 wants to communicate with PC2, PC1 has to forward the packet to switch A, switch A has to forward the packet to the router, which is the gateway. So it will look into its routing table and see that in order to reach 10.1.1.2, it has to go out of interface. This is one interface, this is interface 2. It has to go out of interface 2. Okay, this routing will happen, and now we'll have PC. Now the packet will reach the PC2. Okay, now like in our example, I mentioned that we have 3 computers in IT, 3 in finance, and 4 in sales, right? Or 3, 3, 4, like, yeah. So if I want to have one more this thing network, right, I'll have to add one more switch, right, switch C, and I'll have to connect the PC over here, right, PC5, which is part of finance, and then this would be a part of, let's say, 10.2.2.1, right, another network. What is happening over here is, in order for this communication to happen, I'm using 1 switch, 2 switch, 3 switch, and 1 router, right? More the number of subdivisions of LAN, more the number of hardware I'm trying to add. This is not cost efficient, right? So this is not cost efficient. So that's why what do? I'll basically use virtual LANs, right? Virtual LANs can be configured on the switches, right? Instead of having so many switches, I'll just have one switch now. Okay, now same thing I can do with one switch. That's what we're going to see. Okay, let's say I have switch A. Okay, I have PC1 connected over here, PC2 connected over here, part of interface 1, interface 2. Now on the switch A, I'll say that interface 1 is part of VLAN 10. So my PC1 will be part of VLAN 10 and my PC2 will be part of VLAN 20. Okay, and now this, for the routing to happen, still it's not possible. I need a router for inter-network routing to happen. Okay, now this is a router and this using one interface of the router. See, I'm saving on the interfaces also over here. And let's say this is interface 24, interface 24. Now this 24 interface will be configured as a trunk port. Okay, it's configured as a trunk port. Whenever a link which carries multiple VLAN traffic, over here this would carry the traffic from VLAN 10 and VLAN 20 also. So it's carrying traffic on one interface from two different VLANs or from two different networks, right? So this can be imagined as, instead of one line, you can imagine it as two lines. Okay, one is for VLAN 10 and the other is for VLAN 20. Make sense? Okay, so this is just to demonstrate. I'll just remove this. Okay, so this job is being done by just one single link by configuring it as trunk port, right? On Cisco devices generally configured as trunk port. This communication is possible. Okay, and over here what do you have? You have interface 24 on router A. Okay, so what do you say? You configure the interface 24. Could be, let's say it's 24 dot the VLAN number is 10 and you will have 24 dot VLAN number 20. Okay, now this IP will be 10.1.1.1 and this will be 192.168.1.1. Okay, so you have converted the 24 into two logical interfaces, 24.10 part of VLAN 10 which has an IP of 192.168.1.1 and 24.20 which is part of VLAN 20 which has an IP of 10.1.1.1. Now the packet will from PC1 will go to switch A, from switch A it will go to router A. Okay, and from router A it will check the routing table. It will see that okay, this has to go out of the interface 24.20 and the packet will be forwarded to switch 2 to switch A and it will go out of the interface 2 to PC2. Okay, so when PC1 sends a packet to the switch A, it does not have any information of VLAN. Okay, and so it is an untagged packet. Okay, remember it's called untagged packet. Once it comes to the switch A, the switch A then sees that okay, it needs to go out of the trunk port 24. Okay, and over here on the trunk port you can have traffic from multiple VLANs. So over here what it will do is, before sending the packet out of 24, it will add that VLAN 10 tag. Okay, VLAN 10 tag will be added. VLAN 10 tag is added. Okay, now it will see that this particular packet is sent out of the 24 on switch A and the 24 on router A is received this packet. It will see that okay, this particular packet belongs to VLAN 10. Okay, now what it will do, it will see the destination address and it will see that the destination is part of VLAN 20. So it will add the VLAN 20 tag over here while sending it out over here, right? It will add VLAN 20 tag. Now this packet comes to switch A with VLAN 20 and it will see that the VLAN 20 packets need to go out of interface 2. So what it will do is it will remove the VLAN 20 tag and it will send the packet to PC2. Okay, so it gets untagged. Yeah, so the packet tagging happens only on the trunk port, and when it goes out to PC1 or PC2 or comes from PC1 or PC2, it is untagged. Okay, so untagged packets, right? So these ports are also called as access ports. Okay, port 1 and 2 are called access port. Make sense? Access port, trunk port. Okay, these two things you have to remember. Okay, now let me give you another example. Okay, let me remove this. Okay, now you know, right? This is a trunk port, and let me remove this router also. Okay, now let's say I have one switch, right? Then 24 I have this connected to another switch B. Okay, now there's no inter network routing. I'm just showing you intra network routing. Okay, I'm just showing you how that 192.168.1.2 is over here. This is also 24. Now let's say I have another PC over here. Let's say this is PC 3 and one more PC over here called PC 4. Okay, now this is connected to PC3, this is connected to PC4. Okay, this is again 1, this is again 2. Now this is again part of 192.168.1.3 and this is 10.1.1.3. okay, again this is part of VLAN 10. I'll configure the same on this switch also on switch B. This is part of VLAN 20. Okay, now PC2 can communicate with PC4. Okay, if PC2 wants to learn about PC4, the broadcast packets will only go to the devices which are part of VLAN 20. Okay, again this is configured as trunk port. Okay, the packets will get tagged at switch A, and switch B will see that this packet is part of VLAN 20, and on switch B it will remove that tag, VLAN 20 tag, and it will forward the packet on interface 2 saying that okay, this packet belongs to VLAN 20, so it has to go out of the interface 2, and PC4 will receive the packet. Okay, now this is how I can use switches also to communicate between each other. Okay, so you have seen how the inter-network routing happens, and how intra-network this communication is happening over here. Both are part of the same network and both are able to communicate like this. Okay, if now let's say there was one more router over here, which is one more PC5, which was also part of 10.1.1.4. Now this communication is simple, you don't need. So here you can see that 10.1.1.4, right? Now this also needs to be part of VLAN 20. Okay, so now we know that PC2 can communicate with PC5 because they're both part of the same VLAN 20. So we also know that PC2 will not be able to communicate with PC3 because they are part of different VLANs, VLAN 20 and VLAN 10. So if PC2 wants to send a broadcast packet, then it will send the packet only to PC5 and PC4 because they're part of the same VLANs. So this is how the broadcast domain is now reduced. Okay, so using these concepts, this is how virtual LAN works. Virtual LANs are configured on switches, and when the packet goes out on the trunk port, they get tagged with the particular VLAN, and once they have to go out on the access port, they get untagged and they are sent out. So I hope you guys understood the concepts of VLAN. I'll share a link with which will have a little more information on this. Please go through it. Let me know if you guys have any questions in the comment section. Please like, share and subscribe. Thank you guys.